Good evening, students. Today we are discussing our practice paper 8 for 2027 A-level batch. And this paper contains mainly 5 MCQs and there is a structured essay question to discuss. And this is our MCQ. And there are 5 questions from the recent topics we discussed in our theory class. Okay. So in last few weeks, we discussed about emission spectrum. Then in last week, actually, we discussed about de Broglie equation. Then earlier we had a discussion on successive ionization energy. So the third question is from there. And yeah, again, last week we did dilution, separation, those topics. And there is MCQ from that too. And finally, there is a limiting reactant, a special topic, chemical limiting reactant MCQ. Okay, so those are the MCQs. I'm basically planning this class to revise you the topics, okay, that we learn in our theory class. I have your answers also with me. Most of you have selected answer 3 for the first MCQ. From the list of emission lines in the hydrogen spectrum given below, correct ascending order of the wavelengths. Okay, correct ascending order of the wavelengths. That's what they are expecting. And it is given 5 emission lines labeling from A to E. And it is mentioned each transition also. For example, first emission line given as A is transiting from third energy level to first energy level. Okay, so that's what it is happening there. So what I'm going to do now, okay, Lama, I'm going to draw the emission lines here. Okay, so I need basically 4 energy levels. So let's put 4 energy levels. You all know that when moving away from the nucleus, energy of energy levels decreases. No, energy of energy levels decreases, and the gap between energy levels, sorry, energy of energy levels increases, and the gap between energy levels decreases when moving away from the nucleus. Okay, so this is our first energy level, second energy level, third and fourth energy levels. First line, which is A, given as the transition from third energy level to first energy level. So electron is jumping from third energy level to first energy level. That is A. And then the B is from second energy level to first energy level. And C from third energy level to second energy level. And D from fourth energy level to second energy level. Okay, D. And finally, E is from fourth energy level to third energy level. So these are the 5 transitions they have given. So it is better to draw like this, then very easy for us to understand the question. I hope you all understand what I'm telling. Okay, right. So after getting these 5 lines, so they are asking you to compare the wavelength. Okay, they are asking you to compare the wavelength. So we had a similar MCQ in a past paper, but in that past paper they ask you to compare not the wavelength, they ask you to compare the energy or the frequency. Okay, but here it is asking you to compare the wavelength. Okay, so now here's the thing. If you are having a higher energy, okay, higher energy, that means it is having a lower wavelength. Okay, because from Planck equation, you know, energy of a photon is equal to Planck constant times frequency. Okay, and then you know you can replace this frequency by writing C over lambda. So according to this one, you can say energy is inversely proportional to the wavelength. Okay, so higher the wavelength, lower the energy, like that. In other words, if I say higher the energy, lower the wavelength. Okay, so now compare these 5 lines and take what is the line with higher energy, and that line should have a lower wavelength. Understand? So now here you can see there is a large length, no? So we can write a simple thing like this. So length of line, length of arrow, simply we can say length of arrow proportional to energy and it is inversely proportional to wavelength. Okay, so for that this diagram we can reduce like this. So if you take from the this one is this A is having the highest energy, then it should have the lowest wavelength, lowest lambda. And this E, it is having the lowest energy, that means highest lambda. So like that you can compare the lines. Understand, Lama? So they are expecting you from the lowest to highest. Okay, so highest, lowest to highest. So lowest wavelength would be there with A, which is the longest arrow, and then you are having a wavelength, a greater wavelength in B, then you are having D, then C, then finally E. This is how the order should go. Understand that one? So A, B, D, C, E. So A, B, D, C, E is the answer 3. So majority of you have had selected that one. Really good. So now I hope everyone understand that one. So don't get confused with the frequency and wavelength and energy, those things. Okay. So if you are having a longer arrow, that means higher energy. That means lower wavelength. Okay, so A should have the lowest wavelength and E should have the highest wavelength. That's how you arrange it. Right, so let's go to the second question. It's about de Broglie wavelength. Okay, de Broglie wavelength of two particles. So the question is asking, de Broglie wavelength of X and Y are 1 nanometer and 6 nanometer respectively. If the mass of X is 3 times the mass of Y, the ratio of the kinetic energies. They're asking for the ratio of the kinetic energies. Okay, ratio of the kinetic energy. So there was a similar question in our tutor also. In some, yeah, we will be discussing that too in the class. Anyway, we will see how to do this question. Huh? So there are two particles, X and Y. Okay, so its de Broglie wavelength is given. De Broglie wavelength is given. First particle, X de Broglie wavelength is 1 nanometer. And this one is 6 nanometer, Y. And the mass of X is 3 times the mass of Y. So if you take the mass as the next step, you can say mass of X is 3 times. If you take this one as M, then X would be 3M. That's what it says, okay? Understand that one now. If the mass of Y is M, that means it says the X is 3 times like the mass of Y, no? So therefore, X should have 3M mass. Okay, so according to the data they are giving, you have to understand that in symbols. Okay, so it is question only telling it as a sentence. You have to take it as a symbols. Okay, for example, if mass of Y is M, you should know the mass of X will be 3M. Understand that one. That is very important. Okay, right. Then they're asking the ratio of the kinetic energies. The ratio of the kinetic energies. Okay. So what we know is de Broglie wavelength is equal to H over mv. So basically, what is de Broglie equation? You just recall a little bit. Einstein said that energy, or we can say waves can behave as particles. Okay, so the particle of energy, we say photons are behaving as particles. Okay, then de Broglie argued later, why why can't the particles behave as waves? Okay, he suggested that if waves are behaving as particles, then particles should obviously behave as waves also. Okay, so by deriving a formula, he showed that this is the relationship between any particle's momentum or mass into velocity and its wavelength. Understand? So this is de Broglie equation, and it is showing you the relationship between the wavelength and the wave character and the particle character of the particles. Understand that? Okay. So according to de Broglie equation, we can take this relationship. Okay. Then again, we need the formula for the kinetic energy. So kinetic energy is half mv square. Half mv square. So the question is asking, what is the ratio between kinetic energy of x to kinetic energy of y? Okay, so that's what the question is asking. Okay, so what should we do next? To get the relationship of ratio of kinetic energies, we need the velocities, isn't it? We need the velocity. So what we know here, the mass and the de Broglie wavelength, we don't know the velocity. So let's use this relationship and derive an expression for the velocity, okay, or speed in other words. So speed or velocity here is equal to h over m lambda, okay, h over m lambda. So then we can say Vx equal to h over mass of m, mass of x is 3m, no? 3m times 1. So anyway, I'm using the same nanometer unit. Okay, Lama, that's actually somewhat wrong. Why? Because we should apply SI units. But anyway, since we are getting the ratio, right, we are getting a ratio here. No? So therefore, this nanometer to nanometer unit simplification will be cancelled. So no point of using actual meter length. Okay, I hope you all got that one. So I'm using just 1 nanometer. And then I can write for Vy h over m into 6 nanometer. Okay, so like that, now we are having expressions for the velocities or speeds. Now we can write ratios for the kinetic energies. Okay, so anyway, half is half anyway getting cancelled, but I'm writing that one to show you. So mass of x is 3m into what is the speed? H over 3m into 1. And here half into m into h over, and here it is squared, no? Over that one, h over 6m squared. Understand, Lama? Okay, so you don't need to write this half and like that. But anyway, to show you a clear idea, I wrote it. Okay, Lama? So then I can cancel it. H and half, they all get cancelled. So here, then it would be 3 into 1 over 3 square to then here 1 over 6 square. Okay, 1 over 6 square. Right. So then here it is 3 into 3. 3 into 3. Here it is 6 into 6. Okay. So then I can cut these things, no? Here it is like 2, 2, right? So 3 or 1 or 4. Okay. So then to simplify it further, I need to multiply the both sides by 4. Then it will be 12 is to 1. This is the answer. 12 is to 1. Okay. So there's answer. Answer 4. So you can take the same answer with several steps, Lamai. Anyway, I wrote it in this way just to make sure that you understand it. Okay. So there is a similar question in 2024 A-level paper. Try that question also. 2024 A-level paper. MCQ, as I remember, MCQ 3 or something. Okay? It's there in the tute. In your atomic structure, third tute, first page, you have that MCQ. Okay. Right. So is there any doubt, Namai? Okay, so Namaste is making a point here. Okay, so she is asking, one of your friend is asking, according to this principle, electron is neither a particle nor a wave. Okay, that statement is wrong, Puta. Okay, according to de Broglie equation, electron is a particle and electron is a wave. It is both at the same time. Understand that now. So we can't say electron is not a particle, electron is not a wave like that. Electron is a particle and electron is a wave at the same time. Okay, so that's how electron is behaving. That's actually electron is a very small particle. In your last week theory classes, I explained you why can't we explain electron and small particles, photons? Why can't we explain them according to the normal Newton mechanics we are seeing in the day-to-day life? Okay, so we need the quantum mechanics to explain those things. Okay, so according to quantum mechanics, small particles can behave as particles, then as waves at the same time. Understood that one? So then you can write that too. Electron or small particles behaving as a wave and particles at the same time. Okay, so what is needed for us is electron. So I write that statement for electrons. Electron behave as wave and particle at the same time. At the same time. That's what we call as what? Wave particle dual behavior. Dual behavior. Understood that? Dual wave particle dual behavior. Right. So we discussed the first MCQ and the second MCQ. I hope it is fine. So 12:1 is the answer. Let's go to the third one. So third MCQ is kind of simple. Let's see your responses for the third MCQ. Yes. Oh, very good. So those who answered, they all got this MCQ correct. Very good. So answer is answer 4 for the third MCQ. Let's see how it is coming. First 4 consistent, or it should be actually my successive. Okay, there's a small typing mistake. It should be successive. First 4 successive ionization energies of 5 elements PQRST are shown below. Okay, so they are asking the 2 elements belonging to the same group. Okay, 2 elements belong in the same group. So the theory is really simple. Okay, so what you have to check this one. Okay, same group elements. Same group means same number of electrons in outer energy level. Okay. In other words, according to successive ionization energies, you can understand that sudden ionization energy increase occur between same between occur when removing the same electron, same number of electrons. Okay, so if you take the answer is SNT. Okay, check the ionization energies of them. The first one is 800, second one is 2400, third one is 3700, and fourth one is 25,000. Okay, so that means you have a clear gap between third and fourth ionization energies. Okay, and if you check it for T, 580, 1800, 2700, but then you have 11,600. Here also a clear gap is there. Okay, so now what you can see here, IE1, IE2, 3 and 4. So there is a clear gap between third and fourth ionization energies. If you put this on into a graph, you will understand it in a better way. So if it is energy and number of electrons, okay, first three electrons are easily removed, and the fourth one is really difficult to remove. So what you can conclude here, these three electrons are easily removed, no? Easily removed. Okay, so therefore they must belong to outer energy level. They must belong to outer energy level. Understand that? And this one, we don't know how many electrons are there. It is not given, no? So anyway, these are there in inner energy level. Okay, so always you have to check the sudden ionization energy increase means you have to check for a value greater than greater than twice the initial value. This is what you have to look for. Understood that one, Lamai? So I just wrote a small review for the MCQ. I hope it is okay with you, right? So when you arrange these successive ionization energies, look for the biggest gap. That's where you are trying to remove the electron from a complete energy level. That's why there is a very high value. Okay, that means the previously removed electrons are there in the outer energy level. Okay, so then take the idea. So in both S and T elements, there are 3 electrons in the outer shell. Okay, so that means they should belong to the same group of the periodic table. So about the periodic table, we are going to discuss that one in our last atomic structure tube, which I'm going to start in the next week. Okay, so in there we will be discussing more about these periodic properties and periodic table especially. Okay, so until that, just keep in mind when the elements are belonging to the same group, they will be having same number of electrons in the outer shell. Okay, right. Is there any question with the third MCQ? Any doubt? Okay, shall we go to the next MCQ, fourth one? So now these two questions, fourth and fifth questions, are from chemical calculations. Okay, so in our last week theory class, we discussed about dilution, separation, those theories. Okay, so just to recall, let's say, what is dilution? Dilution is addition of water. Okay, and what is separation? Separation is, the name implies the meaning. You are taking a small portion of a given solution. Okay, right. So I'll explain further when I'm discussing the question. First of all, I'm going to draw a diagram for the data given here. Okay, when you are answering the questions, also try to go with the diagram. It is more easy and you will not miss anything. Okay, so now there is a 20 cubic centimeter H2SO4 solution, and you are diluting it. That means you are adding water. Okay, 10 times diluted to 10 times. Diluted to 10 times means the final volume will be 200 cubic centimeter. Okay, so here it says diluted to 10 times. Okay, I'm going to share the, okay, diluted to 10 times. Okay, 10 times. That means VF, final volume, will be initial volume into 10. That's what it means. Okay, right. And then you are taking 50 milliliters from this solution. So you are taking a 50 milliliter portion. Then again, you are adding water. You are adding water until the total volume is 250 cubic centimeters. Okay, so then you are again separating a small portion of 25 milliliters or centimeter cube. So in this solution, it is telling in this solution, they have found that H plus is there 0.0004 moles. Okay, so what they're asking is the concentration of H2SO4 concentration of this initial solution. That's what they're asking. Okay, Lama, right? So now let's look at the diagrams. Okay, so here what we are doing, adding of water is dilution. So this is dilution 1. Okay, and then from the diluted solution, can you see we are separating a small portion. Okay, so this is separation. So it is, let's label it as separation 1. Okay, and here you have another dilution. So this is dilution 2, and this is the final separation 2. Okay, so dilution, separation, and another dilution, another separation. Okay, right. Then so what's basically happens during dilution? Dilution. So when you add water, number of moles of solute, which is H2SO4 here, number of moles of that solute is not going to change. Only the total volume will increase. Only the total volume will increase. As a result, the solution will be diluted, or in other words, concentration will decrease. Okay, concentration will decrease. Then what happens when you separate? When you separate a small portion, what is happening? The number of moles is going to now decrease, because there were large moles here, but you are only separating a small part, no? So therefore number of moles will decrease. Okay, then but concentration is not going to change. Okay, it's like a drinking a tea, isn't it? So when you drink a tea, let's say the sugar level is very high in that tea. So what you are doing, you are adding some water, then you are diluting the tea, and then you drink. Okay, so when you are adding water, the moles of sugar is not going to change, no? But it is spread in larger volume, therefore the concentration will decrease. So when you drink that tea, what happens? You are taking a sip, and after sip, no? So during that, the concentration is not going to change, but you are drinking it a little by little. Okay, so number of moles of sugar in each sip is a low value. Okay, so like that, understand what is happening during this dilution and separation. Okay, so we are not asked to teach this one as a separate topic in theory, but anyway, doing this will be very useful to you when doing future chemical calculations. Okay, that's why I'm taking this one as a separate topic. I hope you all get the benefit of this thing. Okay, so now I can see most of you are doing really well. I'm really happy, and I want you all to be at the same level. Okay, therefore try. Okay? Right, so we can write during actually it was there in the theory tube. No need to write again. So let's simplify the question. Right, so the what I asked you, just think the number of moles of this uh, sulfuric available as X. So let's say here you have X moles. So when you dilute, like I said, number of moles is not going to change. No? Therefore, in this 200, you have same number of moles of sulfuric. Okay. So then when you separate a portion of 50, then number of moles is going to decrease. So 50 is 1/4 of the 200, isn't it? That means you have to, here the number of moles will be X division 4. Understood? Because if there are, yes, here's what you are, how you have to think. Okay, in 200 if you have X, in 50 then you have X over 4. It's direct proportions. Okay, then again you are diluting, no? So number of moles is not going to change. Here also you will have x over 4. And then again you are diluting, so separating. So here the 10 times. So here it will be x over 40. Okay, x over 40. So before going any further, I hope you all remember we did a similar question in our theory class. Okay, but this one, the one I gave you, is little bit advanced than that one. Okay, so one step is taken forward. So what's the difference? Huh? What's the difference? Here, they didn't give you the sulfuric moles. No? What they give is what? The moles of H plus. The moles of H plus. So from these moles of H plus, you need to calculate how many sulfuric moles are there. Okay. So now think, what is sulfuric? Sulfuric is an acid that can release two H pluses. No, according to O-level theories, you know acids are the compounds that releases H plus. No, you will learn few more things in A levels later, right? So let's say if you are having X moles of this one, then you will be having 2X moles of H pluses, no? Isn't it? So then again, this H plus moles will be equal to what? You have to multiply this one by 2. That means 2x over 40. Okay, 2x over 40. Now you can simplify and see. So if 2x over 40 is equal to, if 2x over 40 is equal to 0.004, another 0.04, then your x will be equal to, you can divide this and see, 20. X will be equal to 0.008 moles. That is the moles of sulfuric. So that means in this 20 cubic centimeters, you have 0.008 moles of sulfuric. Is that clear? That's not the end, but see whether there are any problem up to here. Okay, done. Then what they're asking is the concentration. So how do we find the concentration? Yeah, so one of you are asking, why didn't I consider sulfate? Yeah, I don't want the sulfate concentration of Buddha. So if one is broken, you'll be having 2 and 1. Understand? So I just want to find how many sulfuric moles are there. Okay, so it is half of the moles of H plus. Understood that? Is the half of the moles of H plus. So think about the ratio. Okay, if 2 of them are there, then one of these should be there. So then you don't need to worry about the sulfate. It's about what do you call this one? Stoichiometry ratio. Okay, so sulfate will be there X number of moles. Okay, so I didn't bother about that one because it is not needed for the question. Okay, then you are writing the review. If you want, you can include sulfate too. Now is that clear? Okay, so the question is asking the number of moles, the concentration of sulfate. So how do we find the concentration? Right? So concentration is moles over volume, right? Moles of solute over volume of the solution. The volume of solution here is 20 cubic centimeters. Let's see how to find that one. So H2SO4 initial concentration is equal to 8 into 10 to the power minus 3 moles. I put it in the scientific notation. And the volume is 20 into 10 to the power minus 3 decimeter cube. Okay, so 8 over 20, 4 over 10, 0.4 moles per decimeter cube. 0.4 moles per decimeter cube. So that is our answer. Understand that one, Lamai? So I think some of you are having a doubt regarding this logic here. Okay, so let's take one sulfuric. In one sulfuric, you have two H pluses and one sulfate. You have two H pluses and one sulfate. That's what we are getting here. So if you know the moles of H pluses, then obviously you can come back and find out how many sulfates were there. Okay. So think about carbon dioxide. For another example, in 1 mole of carbon dioxide, you have 1 mole of carbon and 2 moles of oxygen, isn't it? Like that. It's a similar thing, huh? It's a similar thing. Shall we go to the last MCQ? Clean gas reacts with oxygen to form carbon dioxide and liquid water. Carbon dioxide and liquid water. And 15 cubic centimeters of ethene was mixed with 60 cubic centimeters of oxygen gas, and the mixture was exploded. All the volumes are obtained at standard temperature and pressure. So shall we highlight that standard temperature and pressure, that part? Standard temperature and pressure, that part? Standard temperature and pressure. So the question is asking the final volume of the product mixture. Okay, so here's how you have to think. So at standard temperature and standard pressure. So standard temperature for the gaseous lesson is 0 Celsius and standard pressure will be 1 atmosphere. Right? So that means these two are constant values, no? These two are constant values. So I told you earlier, Lamai, gases are showing this PV equal nRT relationship. Okay, so R is anyway a constant and T is also a constant and your pressure is a constant too. So according to that, we can say volume directly proportional to moles, remember? Therefore, finally we can say, okay, volume ratios are equal to molar ratios, isn't it? So when we get a reaction or something, then it would be equal to stoichiometry ratios also. Okay, so that's how we are going to do this question. Okay, so let's write the balance reaction. So let's write the balance reaction. So we are having C2H4. It's a gas, an oxygen gas, and it is giving carbon dioxide gas and water. And it says water is at liquid state. So there are 4 hydrogen atoms and 2 carbon atoms. So there should be 2 carbon dioxide and 2 water molecules. Okay. So here 4 oxygen and 2 oxygen, altogether 6 oxygen. That means 3 O2. So their stoichiometry ratios will be 1:3:2:2. Understood? So now we are going to see, the question is telling that we have 15 cubic centimeters of ethane and then we have 60 cubic centimeters of O2. Okay, Lamai, so these are the gas volumes added. So now the question is giving you data regarding 2 reactants. So if the question is giving you data regarding 2 or 3 or more than 1 reactant, we are not sure about which reactant is going to completely consume. We have to find it by using the ratios. Okay, so we call that question method as limiting reactant questions. Okay, so for that we are using ARR method, added, reacted, and remaining method. Okay, so here the special thing is this was taught to you as a special type of ARR question. The special thing is here the molar ratios and stoichiometry ratios can be taken by volumes also. Okay, so therefore we don't need the moles, here, instead of moles, you can use the given volumes for the comparison. Understand? So let's treat these moles, treat these volumes like moles. Okay. Then we can do the question. Right. So if 1 is there, then 3 of oxygen should be there. So let's say if you are having 15 of this one, then you will be needing 3 times like that, 45 of oxygen. So that means oxygen is the limiting reactant. Sorry, oxygen is having excess. Can you see? Okay, so all C2H4 will react, and here only 45 will react. So let's say if you want to completely consume this oxygen, how many moles of C2H4 you need? To react with 3, you need 1. To react with 60, you will be needing 20. But you don't have 20. Can you see? So therefore, C2H4 is not enough. So therefore, it is our limiting reactant. Limiting reactant. So limiting reactant will be completely consumed. ARR. So here's nothing remaining. Here only 15 will remain. And I didn't complete this part also. If 1 is consumed, 2 will be formed. So if 15 is consumed, 30 of this one should be formed. And here 30 and 30 will be there. So the question is asking, don't be hurried. Question is asking the final volume of the mixture, resulting mixture. And remember, since we are taking the measurements in standard temperature and pressure, at these conditions, H2O is a liquid. Water is a liquid. So therefore, this is a liquid. This is not a volume for the gases. Okay. And only gaseous mixture is this one. So you will be having 45 cubic centimeters in gaseous state. Gaseous state. Okay, so since it is a liquid llama, you can't write this 30 also, okay, because 30 is there by assuming it as a gas. Okay, so it's not a gas now, so therefore it is okay to say that 30 of water vapor is formed, but anyway, if it is a liquid, then can't take it as the 30 cubic centimeter because it is there for gases. Yeah, you're asking during the explosion, wouldn't the temperature increases? Yes, it increases. It increases, but they says after the reaction, they bring all the products to the room temperature. It says in the question, no? It is said in the question. So all the measurements are taking at standard temperature and pressure. See here, all the gas volumes are obtained at standard temperature and pressure. Okay, so it might be a little confusing the way they view the question, but try to understand, Lamai, and note down these things, and just try to remember the question. Okay, so you have to remember, okay, there was a question like this, and this is the method of the question like that. Study. So in these week classes, I'm going to give you a plan about how to do these studies. Now, we've been doing our chemistry class for like 2 months, no? So we have done like 8 practice papers. Okay, that means 8 weeks, 8 practice papers. So now it is time for you to start studying, targeting the A-level exam. Okay, because you will only have similar nearly another 24 months. Okay, so now 2 months have been passed, isn't it? So then you should think about your A-level exam, Lamai. So when you study weekly, monthly, there will be no stress for you at the end of this time period. Okay, so our class, the theme is stress free. That means we are not trying to give you any stress. Okay, so think about that, and all the theory parts and everything will be covered perfectly and on time. And what you have to do, just try and do and repeat what we are saying for you to do. Okay, so the first thing, learn the theories properly. Okay, during the class, and take notes and go home and refer them again. And what you must do is the paper then. Okay, because paper is basically revising you the theories from not only from the last week, theories from the way before. Okay, so it is very important. and then you can practice those papers again and again and again. Okay, so there are the PDFs and all. You can take printouts and then you can redo the paper again and you can watch the recording if you want. Okay, so everything is there. This is the perfect plan for you in order to get the best results in the A-levels. Best results means A. Okay, not just A, you can get more than 85 marks for the chemistry, and according to our other subject, GANS is also doing the similar plan. Okay, so two main subjects. Okay, two main subjects. Think about that. Okay, this is the place where you can get the best results. Okay, so try this one. Okay, so your reviews are going to be checked in the class also. So one of you asking for the some ideas, some guidance for the studying and all. So anyway, there is a small leaflet that I'm giving to you in your next week classes. So I'll explain that during the class. So it will be beneficial. Okay. Then in the next paper class also, I'll do the same thing after you are having that sheet of paper, because that contain the whole plan. Okay. Right. Because I'm so confident about my plan, our plan, because in 2027, 2026 A-level batch, they are now performing really, really well. Now students are searching for us. Who are these teachers and all like that? Because we implemented this plan from 2026 A-level. Okay. So now you guys are also getting the benefit of that. So don't worry. But the thing you have to do is just don't forget. Okay, so maybe you can't, you may be not able to write the review for 1 week, but it's fine. But in the next week, you have to cover that task also. Okay. Right. Now let's discuss this structured essay question. Atomic spectrum is important in finding the information of atoms. Atomic emission spectrum of hydrogen is a line spectrum. The spectral lines occur as several series of lines. Okay, so some introduction is given. And X, Y, Z are the excited electrons in fourth energy level. Okay, so remember that one, it is underlined also. So X, Y, Z are electrons and they are in the fourth energy level. Fourth energy level. So there are 3 electrons and they are in the fourth energy level. Then it says below is how they come back to the ground state. Okay, so it is describing X electron. It is reaching the first energy level by transferring between successive energy levels, and then the Y, it is first fall into the second energy level, then to the first energy level. So let's draw 4 energy levels. Okay, N equal 1, 2, 3, and 4. Okay, students, now look at this one. X is reaching to the first energy level by, X is right here, no? We first come to this one, and then it come to this one, and finally here. So this is how X is transmitted. Then your Y is jumping to the second energy level directly, and then it is jumping again to the first energy level. This is how Y electron is transmitted. And then Z electron descending first energy level directly by one transmission. So this is your Z, and it is directly jumping to the first energy level. There's only one transition. Okay. Right. So below are the spectral lines. They have given some spectral lines also. So it is marked 700 nanometer and 400 nanometer also. And there is one line here, and there are 2 lines here, and there are 2 lines here. They have labeled it as 1, 2, 3, 4, and 5. Okay. Right. Now let's go to the questions. They are in the next page. So they're asking you number or numbers of the spectral lines that is relevant to the transitions of X electron. Okay, now here's the thing, Lama. Here's the thing. Now, what is 400 and 700? Let's think about that values. Why those are really special? 400 and 700 means what? 400 and 700. 400 and 700 is the visible region. So now these transitions are there in the visible region. Visible region. So I'm going to draw that one once again, because anyway that will be needed for us. It is 400 here and 700 here. There are two lines, 2 and 3. One is here, and 4 and 5 also here. Okay, so then these lines are there in the visible region. Visible region. And what about this one? What is this region? It is greater than 400. Sorry, greater than 700. Can I see the answer, Lama? Can you send all that one to the chat? Wavelength greater than 700. It is which region? Greater than 700? Yes. Okay, good. Infrared region. Good. Infrared region. So this one is IR, in infrared region. And here, then this must be UV region. So according to these transitions, okay, one transition will be there in the infrared region, and two transitions will be there in the visible region, and two transitions will be there in the UV region. Okay, UV region. Now think, if you look at the transitions, so you can see electrons are jumping to, first energy level. Then they are jumping to second energy level. You can see like those transitions. Okay. So we can again write about this X. So first of all, from N is from 4 to 3, then 3 to 2, and 2 to 1 is regarding X. And Y is giving 4 to 2 and 2 to 1. Z is giving 4 to 2, 4 to 1, sorry, 4 to 1 directly. Okay, and from these transitions, Lamai, now you know there are several series of spectral lines, Lyman series, Balmer series, and Paschen series, like that. So now tell me, okay, so those who are falling to the first energy level, those lines are belonging to the what? Lyman series. Lyman series. Okay. So then therefore this 4 to 1 transition, 2 to 1 transition is repeated. Two transitions are there. So those are Lyman series transitions. Understand? Lyman series transition. Okay. So Lyman series is there in the UV region now. UV region now. Okay. So 4 to 1 and 2 to 1. So what is having the higher energy? 4 to 1 is high energy. High energy. Therefore, the higher energy means, Lama, to this side, energy increases. Wavelength decreases, energy increases. Therefore, this transition is the higher transition. Okay. So this is the fifth line. Okay, fifth line. So here Z is showing the fifth spectral line. So like that we can conclude. Then this one should show the fourth spectral line. Okay, Lama, is there any doubt about that one? That's the logic of the question basically. I hope you all understand. But anyway, ask if there is any doubt the way I got the answer. Is that clear? So when the electrons are falling to first energy level, they belong to the UV region. So 2 to 1, 4 to 1. 4 to 1 is having high energy, should be there in the further to the right in our diagram. Okay, so that means it is the fifth one, and these are the fourth one. Okay, so then those who are fall into the second energy level, that is visible region, Balmer series. Okay, so you can see there are two lines that belong to the Balmer series. From that, this is having the high energy. Okay, so high energy line is the third one, so it must be the third spectral line. Okay, 4 to 2. So now this is third spectral line, and this is our second spectral line. Then those who are falling to the falling to the third energy level, that is Partian series. So here's our Partian series now. Understand? So these are Balmer series, and this is Partian series, like Partian series. So in that way, we can analyze, no? Isn't it? So they are expecting you to write now in front of X. You can write X is showing what? 1, 2, and 4 transitions. Y is showing 3 and 4 transition. Z is showing the 5th transition. These are the answers. Okay. Is there any problem regarding that, Lama? Regarding the first part? And they expect you to write about these transitions, region, and the series of spectrum. I think we did already discuss that one. I'm going to show you the answer of that part. Okay, can you all see, Lama? So I think you can mark this also well. So the line 1 is infrared region, it is Partian. 2 and 3 are visible, and 4 and 5 are ultraviolet. That's how you should write the answers. Okay, now let's go to the third one. They are asking you to draw the spectral lines now. Okay, to draw the spectral lines. Let's see how we can do that. They're asking you to draw the spectral lines. So 4 energy levels are given. N equal 1, N equal 2, N equal 3, N equal 4. Right. So the first one, here this is in the IR region. You have to draw it like this, 4 to 3. 4 to 3. And then second line, okay, you have to match the relative position, okay. Second emission line is from 3 to 2, and third emission line is from 4 to 2, and the fourth emission line is from 2 to 1, 2 to 1, and fifth emission line is from directly 4 to 1. Okay, so 1, 2, 3, and 4 and 5. You have to label them also. Is that clear, Lama? So they gave this diagram under the energy levels, no? So you have to draw according to the matching relative positions. Okay. Is there any doubt? Let's go and check the answer of that one. You have to name them as XY also, no? I forgot that one. So first one you can see next, no? X, and second one Y, X, sorry, and also X. And third one you will be seeing in Y. And fourth one you will be seeing in both X and Y. And fifth one you will be seeing only in Z. I'll label them like that. Okay, so that's how I offered the marks. So for the 5 lines, 10 marks. You have to label that also to get the 5 marks. Okay, sorry, 10 marks. So without labeling, that won't be that much useful, no? Okay, so let's see the last part of the question. Now they're asking you to do a small calculation. here the value of the line with minimum wavelength 102.5 nanometers, minimum wavelength, and find the energy of 1 mole of photon. So what is the line with minimum wavelength here? Minimum wavelength means maximum energy. Maximum energy. Remember, we discussed our first question related to this, no? So what is the line with the maximum energy? Maximum energy line is with this with Z. Z line, no? Okay, so anyway, it's not that important. They didn't ask what is the line or anything. So anyway, you need to find the energy of 1 mole of photon. Okay, right. I'm going to use some space from the board. I'm going to erase some. So do you want to any doubt, Lama? Anything to clarify? Okay, so these are term test level questions. Okay, to practice these. Usually my students are getting the highest marks in their schools. Okay, so I know my 2027 students are doing the same thing. I don't have to worry, no? So the secret is these questions, Lama. Nothing else, right? I'm teaching the same thing as other teachers, no, but the paper discussion is important. The discussion I'm giving and the discussion you are writing, you are writing is very important. Right, so wavelength is 102.5 nanometers. Okay, so it's asking the energy of 1 mole of photons. We are using Hc over lambda into Avogadro constant formula. Okay, so if it is a structured essay question, it's better to write like this also. 102.5 nanometers. You can say energy of 1 photon. Energy of 1 photon E is equal to Hc over lambda. Here is energy of 1 mole of photon. Right. So now we're going to apply the values. 6.626 into 10 to the power minus 34 joule seconds. And 3 into 10 to the power 8 meters per second. And Avogadro constant 6.022 into 10 to the power 23 per mole. And lambda, it is 102.5 nanometers. 102.5 into 10 to the power 9 minus 9 meters. So 1.025 into 10 to the power minus 7 meters. Okay, so I'm going to apply that value. Right. I hope you saw the another data I gave just to make sure that you get the correct answer. Help to simplify. Okay. So this is actually the question I gave 2026 A-level batch for their first evaluation test. Okay, this is a test question. Huh? So normally evaluation tests are fixed for the exam standards. So you'll be having good questions there. I'm not telling hard, but they are good questions. Okay, so logic is really good. So this is some question I gave. This is the question I gave for the last batch for their first test. Okay, right. So minus 34, 8, and 23, and minus 7. So minus 7 comes above and it becomes 15, and 23, 33, 38. So 10 to the power 4 will be there. Okay, 10 to the power 4 will be there. Yeah, that part is not there in the, no, that was there, no, in the question. Sorry. Anyway, so this one is simplified to give you 116.78. Okay, so that into 10 to the power 4. This is given as a data. So joules per mole. Okay, you can keep the value like this, or you can put it into kilojoules too. 1167.8 kilojoules per mole. That also okay with the answer. This my 10 to the power is correct. Minus 34 plus 23 minus 11 minus 3. Yeah. Okay. So is there any question, Lama, from this part? Any doubts? Then I gave you another small question. Actually, this was not included in the original paper I gave you. But anyway, look at the working, okay? If the energy in the first energy level of hydrogen is minus 1312, what is the ionization and what is the energy in the fourth energy level? So, you know, this transition is there coming from the fourth energy level. So, this 1167.8 is the energy gap between the first and fourth energy levels. So, what you have to do simply, okay, apply this formula and get the energy of the fourth energy level. Okay, Lama, is that clear to you all? There is an additional question. Add that one to your paper review. Okay, it is not there in the paper, but please add it to the paper review. Is that clear? Because the energy we just found is the energy difference between first and fourth energy levels. Okay, students? First and fourth energy levels. Right, that means this Z line fourth and first energy level. If you know the energy of the first energy level, then you can use this difference to find the energy of the fourth energy level. So, right? Right. Okay, so that's the end of the paper. So I hope you all learned something new today. And okay, so if you are have some doubts or the problems with the questions or any reviews I gave you, you can always speak to me during the class, or you can contact me through WhatsApp or your call. It's fine. Okay, just ask me. Don't keep any doubts. Okay, Lama? Don't keep any doubts. Please ask. I can further explain. So I'm giving here some common explanation for to match you all. But if you are having doubts further, you may have doubts. So please ask. Good night, everyone. Study well, and see you again in next week with our paper 9.